So moving right on here, we're going to dive into our next talk with Al HESHMATI from TDK. He's the VP of Software and Systems. This is really building on the theme as well on a perspective on the trajectory from custom intelligence sensors to broad market adoption of smart platforms. Please everyone welcome Al.
Again, as I was introduced, my name is Al HESHMATI. I'm with TDK. I'll share with you today a little bit of my own perspective of how some of these technologies get adopted, and frankly, maybe through that, tell you a little bit about my own background. So I've been at TDK for a good 6-7 years. I joined TDK when the company I was with at the time, InventSense, was acquired. InventSense, the claim to fame has been sensors. It started with motion sensors, accelerometers, and gyros, and now into microphones, pressure sensors, a lot of other things. I joined InventSense in 2012, so a decade ago now. And the reason I joined InventSense at the time was because I saw the same potential in sensors as I'd seen in the early part of my career that I'll touch on the next slide. And it hasn't disappointed. I mean, this whole area of sensors and the propagation of sensors in a lot of the things that we use every day has been amazing. And again, honestly, this is my first tinyML conference, by the way. And again, the reason I'm excited to be here is because I see the significant potential with respect to using lots of different sensors in creative ways to bring the next level of intelligence and integration and functionality into the various different applications that we all would want to pursue. But that gives you a little bit of sense about where I come from. I was fortunate enough, a few decades ago to fall into doing GPS work. As I like to tell some of the youngsters, you guys are just spoiled. Nowadays you've got 4 or 5 different constellation of satellites going around. You've got all these layers and layers of technology that's already been in place for the last few decades, developed in the last few decades. Lots and lots of innovations that have come together to use the sort of technology that we all rely on today with respect to GPS. But the reality is the early days wasn't like that. Again, I remember the days where we're talking about hardware, GPS receiver hardware engines, and the cool thing was, I've got 2 channels, I've got 3 channels, heck, I've got 6 channels of GPS trackers. Well, again, fast forward a couple of decades, and what you're really looking at is these, multi parallel processor engines embedded in these tiny silicons that are essentially powering these hundreds of millions of handsets that are all enabled with GPS. A little bit of, again, personal history. First job out of school, I'd fallen into doing this GPS works. My parents are proud, kids graduated college, so they're going around, what do you do? There's a family reunion. What do you do? And I'm excited, telling them all about, these satellites are going around, and we're building these GPS receivers, they're tracking them, they're able to tell you what, where you are, so on and so forth. They look at me. Okay, next. By the way, they had 8 kids. So there was a lot of next going around. It's obvious that they didn't really appreciate what it was, but great, you got a job. My mom is now 94 years old. She knows Uber really well. She knows Google Maps really well, and so on and so forth. So the beauty of a fundamental ubiquitous technology such as GPS is the fact that honestly most people don't even think about it. It's just there. And what we really care about is, the applications that it's enabling. And by the way, I mean, again, a lot of the consumer applications we all know about. But the thing to sort of take away from this is that the volumes of adoption with respect to handset, that was obviously the volume adoption, really came about first and foremost because of the E911 mandate. So sometime in 2005, 2006, U.S. Imposed a mandate that said, hey, if you're using a cellular phone, we want you to be able to actually locate the caller who calls for an E911 service. And that became the significant motivation with respect to actually getting GPS receivers in these handsets in the first place. It took a few years before you saw some of these other applications that we now all, know and love and use on daily basis. Well, not always love, but, most of the time. But the inflection point, the adoption, initial adoption really came because of that mandated thing. And by the way, that didn't happen by accident either. So if you look at it, amongst those of us in the industry for the last few decades, there's been all kinds of religious wars of, my engine versus my hardware implementation. Hey, I can, track, a dB lower or higher, or this, that, or the other. But at the end of the day, there's layers and layers of innovation that has really led to this becoming a viable solution in these tiny little devices, anything from high precision assisted GPS, things that you don't even think about, layers of software assistance that's floating around these systems from a network perspective that's making these things possible, to all kinds of other bits and pieces. But the reality of it was there were competing technologies at the time with respect to the E911 mandate. It was only because the GPS community came together as well as it did to really establish itself as the key alternative for meeting this mandate. And that was really one of the big drivers for the volumes being put out there, and then obviously as you get to the volumes, the costs and power reductions came with it. There's a lot of innovation driven by that. But there's also a lot of commerce, anything from telematics and people keeping track of their material floating around the earth, to drones that we all know and love, things like use of GPS in construction and farming and automation, and of course we're all expecting to have our ADAS and autonomous vehicles one of these years. So this is, again, GPS has become a fundamental technology that's really centered in a lot of these types of applications. And of course, a lot of it is all enabled by these layers and layers of system and software design. So coming back to the Edge AI, and again, my joining, I'm using up my time on the first slide here. How much time do I have? Davis is gone. Anyways, so Edge AI, lots of potential. Again, with respect to consumer application, there's actually a lot that's already been done. And again, there are all kinds of examples of these sensors in handsets and wearables and what have you. And so again, I'm not going to do a lot of time on this. We're seeing some good examples in some of these other areas, smart cities, lighting, that kind of stuff is some good examples. Industrial manufacturing, a little slower adoption, but again, we'll see a lot of activities already. And again, I look at this sort of just the perspective of IMUs as an example. You can do the same thing with cameras, but given my background and experience with InventSense, I figured it would be a good one to look at. InventSense claim to fame was actually enabling the first consumer high-volume use of gyros. This was in the Nintendo Wii games, and that's what started the adoption. Then, of course, our friends in Cupertino followed by integrating IMUs in their iPhone 2 or 3 or somewhere around there. Again, it's been a few years. And that sort of seeded the market for adoption. But now, as you look at it, you got a lot of other consumer applications. Got all these nice cameras on these phones. A lot of them use IMUs for image stabilization, as an example. Again, as consumers, we don't always necessarily consider all the underlying technologies, but that's ultimately what's going on. And of course, you got a lot of these other applications that are enabled by much higher precision IMU sensors now, in some ways much lower power and better intelligence on chip. Again, a quick look back. We all remember the Fitbits. Great device, by the way, for their time. But nowadays, you got all these sensor-packed smartwatches, doing a whole heck of a lot more than just step detectors or calorie and distance count. And again, the latest was a good talk about earables. In the old days, again, these earbuds used accelerometers primarily for tap and shake detection. Pedometers, maybe some level of heart rate monitoring. Now you've got the latest version of these TWS devices that are giving you concert quality spatial audio, where they're literally tracking your head movement and changing the sound based on your direction of head movement, all the way to literally tracking bone conductivity and being able to detect whether you as a user are speaking, or if it's somebody next to you saying, "Hey Alexa," and knowing whether or not they should respond. So again, you see all these things. I'm not going to bore going through all the various different ways in which we consider these things, but ultimately, looking at the last 10 years, you're looking at literally 10x power consumption, performance, and functionality improvements, if not more. So at the end of the day, what does it take to actually get these things adopted more broadly? And again, first and foremost, there needs to be a defined application, something that would make sense for silicon providers who think in terms of tens and hundreds of millions. Does it make sense for me to add an additional bit of hardware functionality into the silicon? And so it's the usual economic parameters, and therefore the needs have to be clear, and the customers need to be there. But ultimately, what you're seeing more and more now, at least with respect to, again, this example of IMU that I mentioned, is that in addition to having the bare sensing functionality, in this case, InventSense has had their own in-house machine learning techniques for a lot of on-chip functionality for some time. What we're moving towards is now a situation where we actually want to open that up more and more for our customers to be able to do their own custom functionality, be it somewhat limited because of the silicon constraints, but at least be able to do certain models of their own, even for very large volume, applications such as handsets or earables and what have you. So that's but ultimately to get there means you have to be able to deliver a well-encapsulated solution, not just silicon, but also the layers of functionality and tooling and support that comes with it in order to be able to ultimately make it that much easier for somebody else to use. Switching gear a little bit, again, tinyML. Tiny is great, and I really believe it. At the end of the day, I'm a big believer in always-on functionality that ultimately can make detections at very low power, and as I said this on this slide, be on the lookout and wake up the big brother. I think we all do a lot of work around these sorts of concepts. Again, this notion of cameras, the Ring doorbell. These are all just a couple of examples. Some of the cool new things that I've seen that I think has some very good potential for us as a community to want to consider is this notion of crowd of tinies. And what I mean by that is really actually the Google earthquake detection scheme is actually a really good example of that. So you got all these accelerometers floating around Android devices. I think they're estimating 2+ billion. And the amazing thing is that, again, these sensors are very low power and they're great detectors. And so really in this case, our friends at Google have actually deployed a concept where essentially they're using them for tracking earthquakes as a crowdsourced data, and then actually being able to collate that data and issue warnings to the areas where they think other people may be impacted. That's pretty cool. And again, this wasn't the intended application for accelerometers as they first put them in these phones, but that has created an interesting opportunity for some of these folks to want to innovate. At the end of the day, the key takeaway that I'd like to have on this slide is that tinyML solutions will be great if they can easily propagate across multiple solutions and multiple applications at the end of the day. As we look at industrial IoT, though, it's a little bit of a different picture. We all want always on being able to track condition-based monitoring, anomaly detection, quality products issues, and that sort of stuff. But the challenge is that there are far too many applications, far too many potential use cases, and there's not just one large volume AI solution that we can provide. So fragmented market with many low volume applications. Again, there was references to the fact that for some of these markets, the killer app is not yet identified. Sometimes it just takes a little bit of time. And then the last point is there seems to be a gap still between us as a development community, in this case focused on tinyML, and ultimately the guys who are running the factories. And we got to figure out a better way to sort of understand their needs and really solve their problems as opposed to pitching our technologies. So at the end of the day, I think the success will come with respect to industrial IoT as we're ultimately solving and addressing some meaningful pain point for some of these applications. So with respect to TDK focus, again, there was actually a mention earlier today. We're building up our intelligent solutions, and tinyML has a lot to do with it. Some of our more recent announcements, again, our acquisition of Kixo was really in line with wanting to grow our capabilities around machine learning and tinyML. And really one of the key initiatives with respect to TDK wanting to go beyond sensors and to the next level of intelligent sensing and intelligent platforms. Again, These are small steps and building blocks, but certainly a couple of our more recent announcements with respect to some of our machine learning framework development platform, as well as the i3 Micro, which is essentially our initial product into industrial IoT. These are all steps in that direction. Rome was not built in one day, and we're not going to, get to the scale of what I described in GPS deployment overnight. But it's actually really exciting to see that, again, machine learning is already developed and deployed in many different applications. But again, not sure that we'll see the trillion sensor mark by the end of 2023, but I'm hopeful that we won't be too far off of that. Thank you.
Thank you very much, Al.